Okay, so question number 13. Distinguish between the terms electronegativity versus electron affinity, covalent bond versus ionic bond, pure covalent bond versus polar covalent. Characterize the types of bonds in terms of electronegativity difference, and energetically, why do ionic and covalent bonds form? So first, electronegativity is the tendency of an atom to attract electrons, and electron affinity is the energy change when an electron is added to a neutral atom or molecule. So this is the definitions of the two terms. And now for the second part of the question, we need to distinguish covalent versus ionic bonds. So first, I'll just define all the different bonds. So you can have a nonpolar covalent bonds, which is when two atoms have equal or similar electronegativity values. And in terms of electronegativity difference, for nonpolar covalent bonds, the difference is around, or the range, can range from 0 to 0.5. So some examples of nonpolar covalent bonds are like diatomic molecules such as nitrogen-nitrogen, so N2, or even the carbon-hydrogen bond, which only has an electronegativity difference of 0.4. So this is nonpolar covalent, and we can have polar covalent, which is when the two atoms have dissimilar electronegativity values. So the change in electronegativity for polar covalent bonds usually around 0.5 to 1.69. So some examples of polar covalent bonds would be like carbon and oxygen, or like hydrogen and oxygen, etc. And the main difference between covalent and ionic bonds is that covalent bonds are between two nonmetals, and it involves the sharing of electrons. Nonmetals. In the case of an ionic bond, this is between a metal and a nonmetal. So the minute you see a metal involved in the bonding, you already know that it is an ionic bond. And in terms of the electronegativity difference in an ionic bond, it is typically greater than 1.7. So an example would be like potassium fluoride. So for Ionic bonds, this is when a metal would give one of its electrons to a non-metal. So you're not sharing the electrons to form the bond. It is when, let's say we had a sodium ion that has one valence electron, and we have a chlorine that has 7. The sodium donates its electron to the chlorine, and this is how sodium chloride is formed. So sodium has a positive charge and the chlorine has a negative charge, and this is what forms the ionic bond. So the junior tutor said that the tendency of an atom and a molecule by which it attracts electrons towards itself in the case of a covalent bond is termed electronegativity. The measurement of electronegativity is not possible directly and has to be calculated from other atomic and molecular properties, while the energy change when an electron is added to a neutral atom or molecule in its gaseous state is known as the electron affinity. Tendency of an atom and a molecule by which it attracts the electrons towards itself in the case of a covalent bond is termed electronegativity. Energy change when an electron is added is electron affinity. Covalent versus ionic. So they show the sharing of electrons between atoms, and ionic is formed through electrostatic attraction between the metal and the non-metal. Okay, and then pure covalent versus polar. This is dependent on the difference in electronegativities. And the formation of two bonds takes place when the electronegativity difference among the atoms exceeds 1.7, it's ionic, and if it's less, then it's 1.7. Okay, so I'll also add the ranges for nonpolar and polar covalent. So this solution is correct. Also, the electronegativity difference, or for nonpolar covalent bonds, ranges from 0 to 0.5. Let's say 0.4. For polar covalent bonds, (0.5 to 1.69). Okay.